Hello, I'm Timothy Priscilla, and today my class and I are differentiating a natural logarithmic function. Here's the problem. Find the derivative of y equals the natural log of the square root of x plus 9. Standard trick, if you're differentiating a function containing a radical, you have to rewrite that radical using an exponent. What exponent will we use in this case? 1/2, I agree. So we're going to rewrite this as the natural log of x plus 9 to the 1/2 power. And I'm not going to start differentiating yet because I notice that I can use the power rule of logarithms. Using the power rule of logarithms, notice I have an exponent that's being applied to the entire argument. Using the power rule of logarithms, I can pick up that 1/2 and move it down in front of the ln. Now that's not a derivative rule. It looks like a derivative rule, the power rule for derivatives, but it isn't. Here's the function that I'm going to differentiate. So now I'm going to differentiate y prime equals, it's a number times the natural log of x plus 9. What am I going to do with that number, that coefficient, the 1/2? I'll bring it down. I'm just going to bring it down and then multiply by the derivative of the natural log of x plus 9. So we have a 1/2 times, to differentiate the natural log of a function of x. Remember, I'd said that to differentiate the natural log of a function of x, our derivative rule, it's going to be a fraction. What goes on the bottom? F of x. The original argument goes on bottom. What goes on top? The derivative of that argument, f prime at x. So, using that, here's the fraction bar. What's going to go down here? We're differentiating the natural log of x plus 9. What's going to go on the bottom? X plus 9. What's going to go on top? The derivative of x plus 9 is just a 1. And we can rewrite that. 1 times 1 is 1 over. I'd write it as 2 times the binomial x plus 9. And this is much easier than leaving that 1/2. And because if you do that, you'd have an x plus 9 to the 1/2 in the denominator. You'd have to differentiate that x plus 1/2 in the numerator, x plus 9 to the 1/2 in the numerator. So it's much easier using that power rule of logarithms.